the program that I write over here is an old program, that is, find the maximum element of an array. You remember we did this program earlier, but here we will be using the concept of arrays and pointers. That is, we will not declare an array like int an, because we don't know what will be the size, how many elements will be entered. Instead, we will actually allocate that many elements of array or that many memory locations which is needed for accommodating the number of elements that will be inputted by the user. What I mean to say is, as I have discussed in the previous program, I will ask from the user printf enter the number of elements. Enter the number of elements. That I will write first. So it is expected that the user will enter the number of elements. I will scan that in n %d ampersand n. %d ampersand n. So these many elements user will enter. So definitely I will have to scan those many elements. I need to firstly declare the n, then I will have to declare, I have to scan those many elements. How to scan? I told you I will be declaring a memory location called A. Now starting from A, whatever is the memory location, starting from A, there will be many memory locations that I will allocate. And in these memory locations, I will keep the elements as if it is in an array, like what happens in an array. Instead of declaring it like int an, I will declare it like int star a, followed by the number of memory locations that are needed. So int n, no doubt, after that I will declare a memory location called a. So how to declare that? Star a. I declared a memory location called a. After that what? After that I will allocate the memory location starting from a. How many? If there are n elements, then for each element being an integer, each element will need how many memory locations? 2 memory locations. So n elements will be needed by the user, 2 memory locations per element. So how many memory locations will be needed? N into 2. So I will write exactly that. I will write printf. So before printf, a is equal to, check out what? Int star, I taught this thing earlier, malloc n into 2. You remember malloc? What does malloc do? Malloc means memory allocation. What are you doing firstly? You are doing int star a. That means there are, the a is a pointer element. That is, a is an address. So a is an address of a memory location. Now starting from that address, you are allocating memory allocation. How many? N elements will be entered by the user. So malloc n into 2. That is n into 2 number of memory locations you allocate. Where do you receive it? You receive it in A. It is as simple as that. A equal to malloc n into 2. Malloc is memory allocation. N number of elements. 2 is the size of each element because it is an integer. So malloc n into 2, receive it in A. But typecast it to int star because after all malloc A is int star A. Malloc will only return an address, but that address is address of an integer. How do you know that? You know that by typecasting it to int star, because over here I will be dealing with integers and a has been declared as int star a. So this is how you declare the elements. A equal to int star n into 2, you declare the memory locations. Now next what? You know that you have declared a, you have declared the memory location starting from a. No doubt it is like an array. That means this is a. This memory location is a plus 2, because a plus 1 rather, which means 2 memory locations after a. This is a plus 2, which means 4 memory locations after a. In this way I continue because each integer will take 2 memory locations. Now I will have to now tell enter the elements one by one. Printf enter the elements one by one. Enter the elements one by one. So it is expected user will now start entering. So for scanning you need a for loop because n elements you need to scan. So for I equal to 0, I less than n, I plus plus, what will you do? Scanf every time. Scanf %d ampersand ai, or you can write, instead of writing ampersand ai, you can write a plus i. A plus I is same as ampersand ai. This is same as ampersand ai. You can write anything. You can write ampersand ai, or you can write a plus I. You have learned this previously. A plus I is the address. Say a plus 1. A plus 1 is this. A plus 1 is this. Means a plus 1 is this, means this is address of a1. So a plus I can write instead of writing ampersand a1. So for I equal to 0, I less than n, scanf %d a plus I. I have got all the elements scanned now. Now I will need to what? Need to see who is the maximum element. For that, another for loop. For I equal to 0, I less than n, I plus plus, if max is greater than ai, instead of writing ai, you can write star of a plus I, possible? So instead of writing ai, I am writing star of a plus I. If max greater than star of a plus I, this is same as, star of a plus I is same as ai. If max greater than star a plus I, what to do? Max equal to a star of a plus I. Max equal to star of a plus I. Again, star of a plus I is same as what? Same as ai. Same as ai. So check this whole thing, how I am doing this. Just let me put the comments in the same indentation. This is called indentation, keeping it in the same column. Anyway, so max equal to star of a plus I. If max greater than star of a plus I, max equal to star of a plus I. That is, you are allocating the maximum number to max, or putting in the maximum number to max. You know, when you go out of this loop, then automatically max contains the maximum element, because every time max is greater than the element that you are scanning, you are putting that element in max. This is wrong, I think. This I have just done wrong. Max is less than. This is not greater. This is less than. Because if it is less than star a plus I, only then you need to change it, no? Because if max is greater, then max is already contain a maximum element. Why will you change? If max is less than the element in question right now, you know that the element in question is the maximum element as of now. So then only you change. Anyway, so this you have done. One thing you have missed out, that is initializing max. What should you initialize max with? You can initialize max to 0. And then you start with the elements. So this way you can continue. Or else you can do another thing, a new thing that I am telling you. You can start with I equal to 1. Start checking from the next element, and you initialize max to the first element. What is the first element? Star A. What is star A? What is star A? Star A is A0. You check this. Star A means content of A. Content of A, what is this? A0. So this is same as A0, because star of A means star of A plus 0. Star of A plus 0 is same as A0. So this is same as A0. You can think of max equal to star A as max of star A plus 0. Star of A plus 0 is same as A0. Anyway, so this is same as A0. So I initialize this and I check from I equal to 1, not from I equal to 0. I have initialized max with the first element, assuming that the first element is the maximum element. Then from the next element, I have kept on checking which one is maximum. So this you have done. So you know now that here you have got the maximum element within max. Printf, the maximum element is, the maximum element is %d. What is that? Max. Is not so? So here you can end the program by writing get ch and say that you will get the maximum element this way. You need an I to be declared. You need a max to be declared. So this thing's done. I think this is fine then. Let me run it. Alt R enter. Okay, error, because I did not comment out this portion. I did not comment out this part of explanation that I have done for you. This is an explanation. So, okay, so let me run it now. Alt R, enter. Enter the number of elements, 7. Enter the elements one by one. 7 with, to start with 2, then 7, then 5, then 6, then 9, then 1, then 4. Done? 7 elements. Who is the maximum? 9. The maximum element is 9. Now here, suppose I was given to print also the index, that is which position is it present in, which element is it? Is it the 5th element? Is it the 6th element? Is it the 7th element? Which one is it? It is the ith element. How do you know it? Every time you are assigning that element to max, you know at that time the ith element is max. So you can always write max position, something like this. Cannot you write? You can always write something like max position. How to do that? Here you write the position of maximum, the maximum position, the position holding or the position max. The position holding the maximum element is the ith position. Is not so? Please understand, you have been told find out that position which holds the maximum element. So that element is held in which position? In the ith position. Now if I use I only, I, then ith position holds the maximum element definitely, because every time I am allocating that ith number to max, that is the position containing the maximum element. So I will come out of this having the maximum element position as position max. So I can write maximum element is %d present in position %d. Present in which position? Position %d. What is that position? Position max. I can run this. See what happens. Position max needs to be declared though. I am trying to get the position which contains, position of the array which contains the maximum element. Is not so? See. Enter the number of elements, 6 elements. 7, 4, 12, 6, 15, 29. Done. The maximum element is 29 present in position 5. Position 5, why? 0, 1, 2, 3, 4, 5. See 6 elements, the last position is 29. 0, 1, 2, 3, 4, 5. It is position 5. But how does the user know that you have started from 0? C starts from 0. But user is a layman. User does not want to start from 0. User wants to start from where? User wants to start from 6th position, na? User wants to start from 1st position, na? So this is position 6 for the user. User counts from 1. So according to the user, 1st position is 7, 2nd position is 4, 3rd position is 12, 4th position is 6, 5th position is 15, 6th position is 29. So user should write think 6. So here you have started from 0, that's why it is showing you 5. So is not it better to do pos max equal to I plus 1? I think you understand why. Because if any position is the maximum element, for user it is the next position. Is not so? But this position max also, you have to understand that the first position may also contain the maximum element, in which it will never enter this if block. If the first position, 0th position in our case, suppose in C programming, it is the 0th position which contains the maximum element, then it will never enter this. Then the max will contain this first number only, 0th number only. In that case, position max will fail to show anything. So it is better to initialize position max to 1, assuming that the first position contains the maximum element. So the maximum element is the first number, put in max, and position max contains the first position, which I am assuming that it contains the maximum element. If any other element contains the maximum, then this will be true, and accordingly position max and max will change. Let me run this program again. Alt R, enter. So enter the number of elements, say 5 or 7 this time. So 23, 76, 19, 84, 20, 15, 29, and so on. 1, 2, 3, 4, 5, 6, 7 already entered. Let's see what it shows. The maximum element is 84 present in position 4. According to you, you may think 0, 1, 2, 3. 84 is present in 0, 1, 2, 3, third position. No. User thinks 23 is first position. 76 is second position. 19 is third position. 84 is fourth position. So according to the user, this is correct. Maximum element is 84, present in position 4. Achha, present in which address? Which address of memory? That also you can print. Present in position %d in address %p. What is that address? That address is, if I is the element, you know actual element is AI, the last AI. So I contains that. So you have to print, what do you need to print over here? You just need to print A plus I. A plus I is the address, or ampersand AI. A plus I is same as ampersand AI, is not so? So you are printing ampersand AI means you are printing that address where it is present. Is not so? Ampersand AI is the address where this maximum element is present, because after all the last AI is there in max. The last AI, which is the maximum element, is there in max, which is the last possible maximum element. After that there can be any number of elements, but the maximum element is present in AI, which has been assigned to max. But after that I kept on increasing, na? So I does not contain that. It is position max which contains. Please understand this. I has incremented I plus plus, I plus plus, I plus plus. I has gone to the last element. So I does not contain the maximum position. I contains the last position. The maximum position is present in position max. But position max is I plus 1. You want position max minus 1 then? Is not it so? So what you want is something like this. A plus position max minus 1. A plus the position max minus 1. Why? Because you have assigned I plus 1 to position max. Position max contains that position which contains the maximum element. But you have incremented I, you have made it 5. Say it is in the fourth position, you have made it 5 for the user to understand. So it is actually A4. Suppose A4 contains the maximum element. A4 contains the maximum element. So what are you assigning to position max? 4 plus 1, 5 you are assigning. A4 contains maximum element. So last time max will be A4. But I plus 1, 5 will go to position max, not 4. But you want the address of A4. So what are you printing over here? The address of A4, because A plus 5, position max is 5 minus 1. You are printing A plus 4. A plus 4 is the address of A4. Is not so? It is basically ampersand A position max minus 1. Is not so? It is the address where it is present. You may print it and see, Alt R, enter the number of elements, 4 elements, 3, 9, 2, 7. The maximum element is 9, present in position 2, in address 07A6, address spelling mistake, I will just correct it. But 07A6, now what does that mean? Where from does the array begin? It tells you that the array begins from 07A4. Because 9 is present in 07A6 means the array begins from 07A4. You can print that and see. You can print that. Where will you print it? Firstly, let me correct this address spelling. D missed out. Anyway, how will I print the address from where it starts? If you print the address over here, printf, you know A, you have hold the max first element. Printf, the elements begin from memory location %p. Where is it present? It is present in A. You can put a /n over here. The elements begin from memory location A, because A contains the first memory location, so elements begin from memory location A. Now you can check out again, Alt R, enter. Enter the number of elements, 7 elements, 6, 9, 15, 12, 19, 4, 194 it happened. Anyway, so 4, 1 more left, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, okay, 2 more left, 17, okay. So 1, 2, 3, 4, 5, 6, 7 elements I entered. Out of these 7 elements, the maximum element is 194, no doubt. Present in position 5. See the position 1, 2, 3, 4, 5. Yes, because user starts counting from 1. So 1 position is 6, 2 position is 9, 3 position is 15, 4 position is 12, 5 position is 194. It is present in address 07D8. If this is 07D8, 194 is present in 07D8, then 12 is present in 07D6, 15 is present in 07D4, 9 is present in 07D2, and 6 is present in 07D0. So the elements begin from memory location 07D0. Have a look at the second line of the screen. Have a look at the second line of the string. The elements begin from memory location 07D0. Absolutely correct. 07D0 contains 6, 07D1 contains 9, 07D2 contains 15, 07D0 contains 6, 07D2 contains 9, 07D4 contains 15, 07D6 contains 12, 07D8 contains 194. So this is absolutely correct. But however, when we write programs, we generally don't print this address. I am printing all this address so that you understand. But we never print addresses in programs because user should not know all these intricate details. Internally, how you stored the address, where you stored it, these details should not be present with the user. So we never print these addresses when we actually write a program. Here I have done it so that you understand. But you generally don't do it. You never actually write the addresses where the elements are present. Okay. So I think you understand this. Achha, what about few floating point numbers? What if this array was float? In that case, this star A had to be float star A. Please understand. If I am dealing with floating point numbers, maximum of the floating point numbers I want to print, in that case I will have to start with float star A. A has to be float star. But remember, n is not float. N is the number of elements. It is not float. I is the iterating variable. It is not float. Max has to be float. Because max is an element. Max has to be float. So yes, max is definitely float. Because max is the maximum element, which is a floating point number. I will be dealing with floating point numbers, and I will try to find the maximum floating point number out of the numbers that I have entered. So this max has to be float. The array, entire array has to be float. So float star A, max. Position max again is the position where it is present. It has to be integer. So this thing's fine. Enter the number of elements, can in ampersand n. But remember, A is a floating point array this time. This array A that I am talking about is now a floating point array. So this A contains, starting from A, this array contains floating point numbers. So A is an address which contains an integer or a floating point. A is an address which contains a floating point. So A is float star A. So when malloc is returning, malloc only returns an address. It does not know whether it will contain integer or float over there. But you typecast it to float so that address starting from there, float variables can be present. So float star malloc n into 2. So the elements begin from memory location A. Again you print it. Enter the elements one by one. You scan them. For I equal to 0, I less than n, scan f. This time not %d. But %f, because the elements themselves are floating point. So I scan those floating point variables. Here, for I equal to 1, max equal to star A, position max equal to 1, I do all the same things. Position max, these things will remain same, be it integer, be it floating point, this logic should be same. Now the maximum element is not %d but %f. Present in position, that position is %d, because that index is again an integer. In address %p, A plus pos max minus 1. So everything else should remain same. Only this thing changes to floating point. Is not it so? So let me run this program again and see what happens. Alt R, enter. Enter the number of elements, 7 again. So enter the elements one by one. So 6.9, 2.3, 5.7, 9.23, 89.1, 56.7. So 6 elements I have entered. Then 23.21. Now let me see. Who is the maximum element? Definitely 89.1. The maximum element is 89.1. It has written 89.099998 because you did not write 0.2 or 0.1f. If you had written that, it would have printed 89.1. Anyway, so 89.099998 is also 89.1. almost. Present in position 5. See why position 5? 1, 6, first position is 6.9 according to the user. Though for you it is 0th position, but for the user it is first position, 6.9. Second position 2.3. Third position 5.7. Fourth position 9.23. Fifth position 89.1. So present in position 5 in address 0A6E. 89.1 is in 0A6E. See, if this is 0A6E, then where is 9.23 present? 4 less than that. This is floating point, don't forget. Each element needs how many memory locations? 4 memory locations. Each element needs 4 memory locations. So if 89.1 is present in 0A6E, where is 9.23 present? 0A, 6D, 6C, 6B, 6A. 9.23 is present in 6A. So that 6A, 6B, 6C, 6D, these 4 togetherly contains 9.23. So 6E contains 89.1. 0A, 6E contains 89.1. So definitely 0A, 6A contains 9.23 because 0A, 6A, 0A, 6B, 0A, 6C, 0A, 6D contains 9.23. So similarly, where is 5.7 present? See, 0A, 6A is 9.23. So 0A, 69, 68, 67, 66. 0A66 is 5.7. Remember, 0A66 is 5.7. So 0A66, 67, 68, 69 is 5.7. Do you get it? 66, 67, 68, 69 is 5.7. So that 0A6A is 9.23. So 0A66 is 5.7. So 65, 64, 63, 62 is 2.3. So that 2, 3, 4, 5, 0A62, 63, 64, 65 is 2.3. So where is 6.9 present? 0A61, is not so? 0A61, 0A60. Before that is 0A5F, 0A5E. 0A5E, 0A5E is the start of 6.9. So 0A5E, 0A5F, 0A60, 0A61 is 6.9. So 2.3 starts from 0A62. So 6.9 is present in 0A5E. Have a look at the second line of the screen. It is showing 0A5E. Yes, the first element begins from 0A5E. You can take a piece of paper and do all these calculations. You know hexadecimal number. After 5E comes 5F. After 5F comes 60. After 60 comes 61. Isn't it so? You calculate this way and you will find that each element has taken 4 memory locations. And this is how they are present internally. But I repeat once more, printing all these addresses and these things are not needed. You generally don't do because user should not be concerned with the addresses of memory locations. So it is always better not to print any memory location, not to print the address. So getting rid of this address being printed is a good thing to do. Here also, getting rid of the address where it is present is a good thing to do. You don't print the address in address %p. That is generally avoided. We never print, we don't show, we do deal with it internally, but never show that to the user. To the user, I never show the addresses because user is not concerned with this. This is the final program which you run. Enter the number of elements, 5 elements, 7.8, 8.9, 34, 8.9, 34, 45.2, 4.5 and 6.1. Who is the maximum one? 45.2. The maximum element is 45.200001 present in position 3. 1, 2, 3, third position. Is not so? So this thing. But wait a minute. How was it working? There is an error that I have made. Many of you are having a question in your mind that this should not be working. This is wrong. Where is it? Many of you have pointed it out early also. See the here. I made a mistake, but still it ran. How? A equal to float star malloc n into 2. Suppose you are saying 7 elements in total. 7 elements in total means in case of float, how many memory locations are needed? 7 into 4, 28, because one memory location needs each one float element needs how many memory locations? 4 memory locations. So if you are wanting 7 elements in total, then how many memory locations will you need? You will need 7 into 4, 28. But see, suppose user has entered 7, n as 7. How many have you allocated? 7 into 2, 14. Take this, say user enters 7. You are declaring 7 into 2, 14. But still, this program is running. This program has run for float. How is it possible? How did it run? It should not have run. I should not have written this as 2. Instead, this should have been n into 4, because float takes 4 memory locations. And you saw that it took 4 memory locations because you also printed the addresses, and you actually find out that the first address to the next first memory location, or the first element's memory location to the next element's memory location, 4 memory locations have been taken. But you had written n into 2. Why? See why. Why it worked. It worked accidentally, might not work always. It worked accidentally, I repeat, might not work always. Here, when you are running this program, all memory locations are almost free. No other programs are running togetherly or parallelly. Say when you run one application in your mobile or in your computer, parallelly many other applications you run. 2 or 3 or 4 applications you run parallelly. When you run different applications parallelly, all those processes, all those applications take memory locations. So your memory locations remain or tend to remain occupied, but over here you are running only one program, only one file you are running at a moment. What does that mean? That means that when you are running this program, all other memory locations are almost free. They are free. So automatically when you were doing malloc, say user has entered 7, you had done malloc 14. So from A, starting from A, you had actually allocated how many? You had allocated 7 memory locations. See, from A, starting from A, suppose you have allocated not 7 but 7 into 2, 14 memory locations. So these 14 memory locations are definitely being used, but along with it, the next 14 locations are also free. The next memory locations are not being used. So using those 14 locations one after the other is not any problem for the program. So you are declaring, you are allocating 7 into 2 or 7 into 2, 14 memory locations. Yes, 14 memory locations you are explicitly allocating. But internally, the rest 14 locations, the other 14 locations coming after that were automatically free. The C program used it. Doesn't matter, it used 7 into 2, 14. You are thinking you have done n into 2, as if 2 memory locations you have allocated. But actually it is using 4 memory locations for the first float number, the next memory locations for the second float number, the next 4 memory locations for the third float number, the next 4 memory locations for the fourth float number. In this way, it kept on using. And you could use, because the rest 14 memory locations which you have not allocated are automatically free. They are using it. It is using it, so it worked. But by chance it worked. If those memory locations were preoccupied by some other programs, then your program would have malfunctioned. I repeat this last point. You needed 7 into 2, 14 memory locations. See, you have written n. User enters 7. You need 7 into 4, 28 memory locations. But you have allocated 7 into 2, 14, because float you have used 7 numbers means 7 into 4, 28 memory locations are needed. But wrongly you wrote n into 2, that is 7 into 2, 14 memory locations were allocated. But 14 memory locations still program worked fine. Because why did it work fine? Because it used the 14 memory locations you allocated. After that, it started using the next memory locations, which are free at the moment. But had it not been free, had some other applications, some running applications used those memory locations, then your program would have started malfunctioning, because those programs, the other programs are already using those memory locations. It would have been unable to use those memory locations, and your program would have started to malfunction. So better is when you write float, not better, you should always do. When it is float, use n into 4. If it is int, use n into 2. When it is say pointer, you are allocating space for a pointer. Is that possible? Yes, possible also. I will show you very soon. If it is a pointer, then also use 2 because pointers takes or addresses take 2 memory locations. However, for the time being, if it is an integer, always n into 2. If there are n numbers, 2 memory locations per number, so n into 2. If it is a float number, 4 memory locations per number, so n into 4. You always use this strategy. But here I will show you another interesting thing. C has got another interesting thing which you can use. Size of. Do you know what is size of? Size of is another interesting thing in C, which or another you can see, as you can see, is a keyword which you can use. Size of actually returns the size of a data type. That is, if you write size of int, it will mean 2. If you write size of float, see size of float, it will mean 4. I repeat, if you write size of int, it will mean 2. If you write size of float, it will mean 4. You understand this? So this is actually, you can write it over here because this is not showing the white color because that part is commented. This line is commented already. I am writing it here. Say size of int, when you are writing size of int, size of is a keyword in C. If you write size of int, it automatically means how much? 2. If you write size of float, it automatically means 4. Similarly, if you write size of int star, what is this? What is int star? Int star is pointer to an integer. Int star is pointer to an integer. If you write int star A is pointer to an integer. So what is A? A is an address. So int star is an address. What is the size of an address? 2 memory locations. Any pointer also takes 2 memory locations. So size of int star is 2. What is size of float star? See, size of int is 2. Size of float is 4. Size of int star is 2. Size of float star is 4 or 2? 2. Because float star is also an address. Float star is not float. If you write float star A, that means A is not a float. A is an address. An address which can contain a floating point number. So any address is 2 memory locations. So float star, int star, all are 2 memory locations. Int is 2 memory locations, but float always takes 4 memory locations. So do you understand the meaning of size of? So this size of, how do you use or why do you need it at all? You actually don't need it as such as of now. Later on it will be having more uses, but at the time being you can think like this, that instead of writing n into 2 or n into 4, it is better writing n into size of that. That is, over here it is float, so you allocate n into size of float. Each float is 4 memory locations, so n into size of float is n into 4. In the previous program, when you were using int, instead of float, these were int. It was an integer array. Then this was int star, and this would have been n into size of int. The number of integers is n into size of int. Each integer is 2 memory locations. So size of int would have worked fine. Here, float, each float is 4 memory locations. Size of float, it will mean 4. So n into 4, it will happen. What will happen is n into 4. So float star malloc n into 4 will work fine. It is n into size of float you are writing. You can replace size of float and write 4. You can replace size of int and write 2. But it is better if you write like this. And moreover, you will use this. You will have its uses, better uses later on. For the time being, you think that I can always use this size of. Let me run this program once more and check out. Alt R, enter. Enter the number of elements 6. Enter the elements 1 by 1, 6, 9, 3, 4, 2, 7. So the maximum element is 9. I have, it was floating point, I have entered all integers, so it has taken 9.000000, present in position 2. Because for the user, 6 is in position 1, 9 is in position 2. However, for you, you know 6 is 0, 0th position, 9 is 1th position. That's why you have used this position max equal to I plus 1. So that user does not get confused about 0 and 1. User always starts from 1. So I think you have understood this. You can run this program again, check this program again. When we come back, we will do some more programs with array with pointers. I will not use array, I will use array in the form of a pointers. I will write one more or two more such programs. But after that, we will learn 2D array and pointers. What is the meaning of 2D array and pointers? There is a relation of 2D arrays also with pointers in a different way. We will learn that. But before that, we will do two more programs with maybe arrays and pointers. Thank you so much. You can take a bit of break and come back.